One of the most interesting things that I like to look at in terms of enzymes are their activity. So, what can we do to speed up enzymes or to slow them down, and how does that play into the human body and all the intricacies of the changes within the human body? So, we're going to talk about how enzyme function changes as a result of some things that may be going on in the body. Okay, so enzyme activity is defined as the rate at which an enzyme catalyzes a reaction. So we know that when you have an enzyme present, it's a catalyst, it's going to speed up the reaction by lowering the activation energy. But we can also look at how fast or how slow that enzyme is able to catalyze the reaction as well, and that's the enzyme activity. So there are a couple different situations that we can look at in terms of enzymes. The first is temperature. These enzymes are proteins, and in our protein denaturation talk, we talked about what happens when you heat up proteins too much. They denature, they lose their 3D shape, and therefore they're going to lose their function as well. And that's fine in D&D if we're talking about eggs, and it's not so great if we're talking about enzymes that you need to do metabolic reactions in your body to keep you alive. That's not a good thing to denature those. So in the human body, your optimal temperature for enzyme function, meaning if you want to get the enzymes to work the fastest at the best rate without denaturing them, you're going to want to have a body temperature between 25 degrees Celsius and 40 degrees Celsius. So as it gets warmer, your enzyme functions faster, your molecules are moving more, but then it really takes a dive bomb beyond 40 degrees. 40 degrees, think of that as being feverish. 101, 102. As soon as you start to get past that point, it is too hot for those proteins and they start to denature, which is why in young kids whose temperatures can fluctuate so much, we really want to be sure we're not letting their fevers get too high because we run the risk of permanent damage to their proteins. Anything below 25 degrees Celsius, your molecules are moving slow, the enzymes are moving slow. The enzymes aren't able to keep up with the reactions needed to keep you alive. So the reactions aren't happening fast enough to keep you alive. So think about somebody who has gone out without a jacket for a prolonged period of time in the middle of winter, somebody who is hypothermic, their reaction rates are slowing down and it may drop to the point where you cannot sustain life. pH is very important for enzymes. As we talked about again in our protein denaturation podcast, if you add an acid or a base to an enzyme, you can denature a protein, rendering it biologically useless. So for the most part in your body, a pH of 7 is optimal. Your enzymes work best, but it really depends on which enzyme. So you have enzymes like pepsin, which function in your stomach. They only function at a pH of 2. They prefer an acidic environment. In fact, that's where they function the best. Or take your small intestine, for example. The small intestine is more basic than the stomach. So trypsin is going to have to function at a higher pH than, say, other enzymes in the body, and especially higher pH than pepsin. Something else we can do to affect the rate at which an enzyme works is to increase that enzyme concentration. So if suddenly we have a lot more enzymes, they can function on a lot more reactants at the same time or on a lot more substrates. So you can add a ton of enzyme to it. Your reaction rate is going to increase with an increase in enzyme concentration. Eventually you're going to hit a plateau though. So it will go up for a little while and then you're going to hit a plateau where you have enough enzymes, you're saturated to work on the reactants that you have present. So that works for a little bit to increase the rate. The other thing we can do is to increase our substrate concentration. Give the enzymes more reactants to catalyze for the reactions. So if you increase that concentration, again, you're going to see that same plateau where it's going to increase for a while and then it's going to plateau because you only have so many enzymes to work with so many substrates. So increasing enzyme concentration and substrate concentration works really well until you hit that maximum point, that plateau. All right, I like this visual because it shows us for both temperature and pH, kind of in the human body where those enzymes are going to work best. So here's your reaction rates maximum right at the top of this peak. That is roughly, and I'm eyeballing this, forgive me, about 37 degrees Celsius. What? So the enzymes in the human body work best at human body temperature. As you start to increase the temperature, notice this sharp decline. Guess what we're doing to our protein catalysts? We're denaturing them. They're not going to function. As you decrease temperature, your reactants are slowing down, your enzymes are not coming in contact with those substrates as frequently, and so your reactions aren't occurring at the same rate. Those will not be life-sustaining, you will die. We also talked about pH. There is an optimal pH, and now this one is a little trickier because we talked about the compartmentalization of the body and how in your stomach, a lower acidity, say if we had pepsin, this may function a lot better at 2. Or if we had trypsin, this may function a lot better closer to 8. So this really does vary a lot more than temperature in the body in terms of enzyme function, depending on what enzyme you're working with. But for the most part, for most enzymes, your optimal pH is right around neutral at 7.